Alright, so now we're going to do a question on the topic of probability. So it says here that 3 unbiased dice are thrown. So that means, right, that actually if you had 3 dice, they're going to be thrown. And the assumption here is that when I throw each one, the probability of, let's say, getting a number 1 is independent of the other numbers that are showing on the other dice. So if I were to get a number 1, what's the probability of getting it? By itself, it's just a number 1 out of the 6 outcomes of the 6 faces. Okay, so that's just for one individual dice. So if I wanted to actually get all the same numbers when I throw the 3 dice, what are the different outcomes that I have to actually consider? There's quite a few actually. Okay, so it could be the outcome of where I get a number 1 and a number 1 and then a number 1. 3 ones are all same numbers. Or it could be 2, 2, and 2. Notice how I got a plus here. The key thing in probability to note is that usually when we say the word or, it's associated with a plus sign. And when we actually have a word and, associated with the multiply. So it could be this situation, 1, 1, 1, or it could be 2, 2, 2, or it could be many, I think you can guess, all the way until 6, 6, 6. Okay, 6 different situations. Okay, so what's the probability of each individual situation? It's pretty simple. What's the probability of getting a number 1? 1 out of 6. Now, and I want another 1. Okay, so it's a probability of 1 over 6, and I want another 1 over number 1, which is a probability 1 out of 6. So if I want all these 3 things to happen at the same time, I'm going to multiply them together. So in English, like I said, if you pronounce it out, I want to get a 1 with a probability of 1 over 6, and then I want to get another 1 with a probability of 1 over 6, and finally, another 1 with a probability of 1 over 6. So this happens actually quite a few times, even in the other situations. You realize the probability of getting 2 is again still 1 out of 6, and then another 2, and then another 2. So you realize I'll have this probabilities appearing 6 times. So if I were to write it actually in a shortcut form, it should look something like this: 6 times of 1 over 6 times 1 over 6 times 1 over 6, which finally gives us an answer of, when I press the calculator, yes, 1 out of 36. So that's the first question, where they all show the same number. So the probability of that happening is a value of 1 out of 36. So how about when I want the total of the 3 numbers to be 17? So if I actually want 3 dice to give me a total of 17, it could be a combination of 6 plus 6 plus 5. It must be a combination, I mean. Okay. However, each dice is unique. So it could be 6, 5, 6, or even 5 and 6 and 6. So these are 3 situations that will actually give me this total of 17. So if I want the probability of total of 17, it could be the situation where I had 6 and then a 6 and then a 5, or 6 and then a 5 and then a 6, or last but not least, probability of 5 and a 6 and a 6. So individually it's very similar to this one. A probability of getting a 6 actually is a 1 out of 6, and then another 6 is 1 out of 6, and then a 5 is 1 out of 6. So you realize I have the same probabilities for the rest, because individually each number is independent of each other. So I have 3 times of this. Simplified, it looks something like this. This is not really necessary, but sometimes a bit lazy to press into the calculator. And when I multiply this out, I'm actually going to get a value of, let me see, 3 times 1 out of 6 times 1 out of 6 times 1 out of 6. 1 out of 72. So 1 over 72 is the answer here. So this is the answer for these 3 questions. The two questions, I mean.